We're going to be covering the topic of a faster way for one-off product engineering. So let's get started. I'll go ahead and release my screen, James, and you can start sharing and we can get underway.
All righty. All right, so this, what you're seeing on my screen today is what we worked on yesterday. Just kind of a simple die wall. It's got some unique solid modeling done to it. Just through adding my own AutoCAD solids for the solid surface. Same with subtops. We can spend a little time on this. I was kind of hoping to spend a little more time going over some of the other tools, the custom product builder tools, which you can use to create, custom cabinetry using either a front profile, top profile, or a side profile. And those tools are pretty neat. But I know we've got some new users joining us, or potential users looking into how this could benefit their company. One of the few things that I enjoy about these tools is that they're really pretty easy to work with. Even if you need to start over, it only usually takes 5 to 10 seconds to build up these products again, which is a huge asset when you're trying to create something custom. If you get far enough down the rabbit hole that you find, oh man, I need to just start over, it's not going to take you long to get back. And that power comes from what we call smart layers. So in the toolbox, under the solid modeling tab, we have our smart layer manager. So our smart layers are split into two different entities. We have vertical entities and extruded entities. So vertical entities are going to be any parts that will be arrayed along your construction path. A construction path is the path that you want this product to follow. So on my screen here, I'm just going to draw something kind of crazy to start. And we'll just give ourselves a kind of a unique wall here. And then when we get to, this would be a construction path. So we would want our product to follow this. And that product would be based on a section that we have drawn. You can see here that I have my smart layers assigned. So I have, looking at the way the material is set up, or these smart layers are set up, I'm giving this layer a name, which will then get turned into a part name when we go to analyze and save this product. I can specify the color. I can select what material I want to use, right? And this is going to go off of the project materials that you have set up. You can also create custom materials on the fly if need be, using the create new material interface. You can give spacing options, what distance do you need, and also how are you going to space those? They're going to be fixed based on that distance that you have specified here, or are you just going to kind of divide the whole length by that amount and then equally distance the quantity. A couple different machining options as far as how we want to, fix these vertical entities. Are we going to use dowels, or are we going to use Dados? It depends on your company, how quickly you want to be able to go from CNC or maybe a saw, to a bench for assembly. I've found in my experience that the quickest, easiest way is to use Dados. There's no guessing, no other machining stations that need to, be added into it. I don't need to take my studs over to, a horizontal boring machine, whether that's an automated machine or just a standalone, pneumatic machine, whatever. I don't have to handle all those parts another time. So in my experience, I've found that Dados work the fastest. Now that may not be the way you want to do that at your company. You can even use it to kind of trick the software into doing screws. Maybe you just want to give screw locations instead of using actual dowels, and those would be drilled into your plates. So, again, you're going to take the guesswork away from your assemblers. They're not going to have to measure anything out. All that's going to be predefined for you. The faster you are on the engineering side and the more you can accomplish on the engineering side, the better it's going to be for the guys out in the shop. Associative joint types. If we've got a wall that is long enough that it needs to break, which in this example with that construction path I just drew, it will be. So we're going to go ahead and decide, how we want to handle that break. We're going to do a single, double, or quad stud. I'm just going to do a double stud. Now it says select entity. We don't have anything drawn at this point, so there's nothing for us to select. Along with the other properties for our entities, our vertical entities anyway, start scribe and end scribe. So it does have to be a positive value. You can't enter a negative value in there to move it the other way. It just doesn't work that way. So positive values will move the studs in from the start and the end of our construction path by whatever specified amount you put in there. This dowel fixed boring height is just an offset from the center of the material. So depending on your shop setup, you may have a fixed table that they're always going to be 3/8 of an inch, regardless of how thick your material is, whether it's an inch or 3/4 or whatever. Your dowels are always going to be placed off of a certain dimension. So you can enter that in here. So for our extruded entities are going to be parts that are extruded along our construction path. So those will be things like plates, your inside and outside panels, nailers. If you're looking at my section here, I've got nailers drawn. One thing you might notice is, I've kind of got this funky shaped stud. Those are corner relief notches. Again, I'm looking for anything I can do to speed up the the assembly side by engineering. By adding these corner relief notches, I don't have to worry about rounded corners coming in from my router, or maybe having to throw a round over bit onto my nailer so I can just slap that in. I can just work quickly and easily off of square parts and get to assembling this thing in no time. With our extruded entities, again, with the properties here, we have different options. Again, we're going to specify our part name, color, and material. Now we've got extrusion max linear length. So you can enter in this field what dimension you want to be the max length for the part, and where do you want it to break, right? So if my parts are coming out of, plywood, 4x8 plywood, minus my margins for my my CNC, 95.5, would probably be a good length for when I would need to break that part. Extrusion spacing, if I need a break, as we can see in the image below, by entering a dimension in here, it's going to space those parts by the amount that you enter in here. So if you're trying to create, let's say, a reveal in wall panels, you could enter in a dimension here, and everywhere that a break occurs, you would have a 1/2 inch, 3/4 inch, whatever you type in there. The start and end offsets are similar to the start and end scribes that we saw in the studs. It's going to move these in a positive amount from the start and end of your construction path. This next option, apply machining, this tells this layer that it's going to need to receive the dowels or it's going to receive your Dados. So it's just an on-off, a true-false setup. Corner negotiation. So we have different options, but before, but after, miter joint, distance from corner. In the example that I had up here, I used the distance from corner, and then just to make sure that I ended up with a single L-shaped piece, I maxed it out. I mean, you don't have to put it in at 999. You could put it at 12 and 12, and it, would give you a little corner here. So let's go back to our other options. None. If we were to select none, basically what that will do is anywhere that you have a corner, it's just going to overlap the parts based on the center of the part. So, if you've got an L-shaped wall, something like that, you're not going to want to put it on none. You're going to want, to select one of these other options. I'm going to change it to miter joint. All right. And, going through the rest of these, we can see the settings that I have set up. So, we can quickly come in and see what kind of corner type we have, any kind of trailing and leading distances for those distance from corner, if they're going to have machining applied and, offsets, et cetera. So you can come through, just make sure that your layers are set up correctly. I do know I need to change some things real quick. So I'm going to, sorry, that needs to be miter. All right. I'm actually going to switch this up. I've got this set up for dowels. I'm just going to do it in this section here. I'm going to erase my dowels out of there. I'm going to modify my shape to allow Dados. I'm just going in 1/4 of an inch into my top and bottom plates here. And then I do need to change that in my smart layer. Now with the Dados, you can give yourself a stop gap and a width gap. I usually will set these at about a 32nd of an inch. It just gives me a little bit of clearance for my material thicknesses. All right, so we are now ready, once we have all of our smart layers set up and we have our section drawn, to be able to extrude this along our construction path. So I can close out of our smart layers. I'll jump into our solid modeling tools now. So onto our interface here. It's really simple. You're just going to follow the instructions here, right? So we're going to add. I was working with different products earlier, so we're going to go with an extruded product starter. We can call this, give this wall a name. We're just going to call it Funky Wall. It's going to ask you to select the construction path. And it's always, a question I get often is, what order should you follow the steps? Well, they're laid out for you right here. If you follow from top to bottom, you're going to have a lot more success with the product. And when I say success, when you start modifying the product, you start adding, supplemental parts, you start adding brakes or copying and moving studs. If you go through and you work with all your extruded parts first, and then you work with your vertical entities, and then you go to your supplemental parts, you're going to have a lot better success with the software. So we're going to start. We're going to add some extruded parts. Now this is a simple wall. Don't think that this is always the case. You can't always just highlight the whole section. if I needed this to not be a cutout and an extruded part, I would want to make sure that I select all of my extruded parts only prior to selecting vertical parts. This is a simple wall, so I can just select my section. I'm going to zoom over here before I hit enter so you can see what happens. All right, so there we go. We've added our wall. We can see that we actually have a break based on our extrusion linear max length. So let me hide all. I can't really hide that, sorry. Let me go into a different view here. All right, so if we look at this in a wireframe, we can see, it's arrayed our studs based on that equal spacing along our construction path. Now, one thing we did set up that we don't see here is I do have a break, right, in my plates, but I don't have my double stud. Well, that's because we couldn't select an entity yet. So we're going to come to our vertical parts, go to our stud, right click and edit. Down here where it says vertical joint associates, we can now select something. Popped up on my other screen. So we can select which entity we want to insert our break or have our breaks follow. I'm going to go with the bottom plate. And then now we can see we've got two studs that were placed at that break. We can, again, we had it follow our bottom plate, so it broke it there. We can move our other breaks to line up by using the extruded tools. So these extruded entity tools down here will allow us to move extruded entities, joints, insert joints, and remove joints. I'm going to move, and you select the parts that you want to move. There are multiple layers on this, so you're going to see that little green line stay there for a moment. But it's going to ask you for a base point, and then another base point or end point, second point on where you want that break. So you can align those breaks. You can actually do multiples. So if let me move that one back. Get them aligned with that. So I'm actually going to move them all. Right. We can do the same thing with all the different things that we see that aren't quite lined up. Just trying to find a good snap point. So we do the same thing, for our outside faces. Right, so now everything is lined up there. Now I didn't set up my section to actually work for a curved wall. It's still using 3/4 inch plywood. Good luck trying to bend that without curving it. The company I came from, when we did any kind of curved walls, we did stacked layers of MDF. Depending on how tight the radius was, we'd either use 1/4 inch or 1/8 inch, kind of a door skin. And we just found we got a lot better product using the MDF versus, a bending ply or curved core. It just held its form a lot more fluidly as we went through these products. If we were to continue to manipulate this, maybe we needed to add some more studs or maybe add some breaks to our panels, we could do so. So I'm going to insert a break here. I'm going to do it for everything, right? So I just added that break to all of my parts, my plates, my inside and outside faces. And again, it's smart enough to know that because I inserted a break in that bottom plate that it threw the double stud in there. So if we didn't need to modify this any further, we are ready to save it. Few ways you can save that. You can save it directly from the interface here. If I had more than one, I'd right click on products and save all checked products as one. In this case, I just have the one wall, so I can save it here. It's going to ask me if I want to save this drawing. And right now it's creating all that, the spreadsheet, it's creating all the machining instructions. So you can see it didn't take very long for it to analyze that and make a Microvellum product. If we jump into the spreadsheet for this, we'll be able to see all the parts that it created for us, all the machining instructions that it created for those parts. And now that product is ready to go to the shop. We could go jump right into a work order, which I know Ed is covering work orders after this session, so I'm not going to jump into any of that. But I mean, these tools are really quite fantastic in my opinion. That's not just because I work with Microvellum. Like I said, I jumped on this long before I started with Microvellum, and have been a huge advocate for these tools ever since. Another way to save this is to use the solid model analyzer for those who have that part of the package as well. These can be separated out depending on what you feel will be most beneficial for your company. Solid model analyzer does not have the extruded tools that we use to build this wall. You would have to draw this wall out using 3D solids and then analyze from there. The other way, if you have the complete package, this is what I had down here. There are parts that I added strictly through AutoCAD, parts that I use the extruded tools for. I would throw this into the solid model analyzer to create a product. Now, I made some modifications, so it doesn't quite look like what we had yesterday. That's my subtop material there. Okay, I just found some tool machining that I didn't have a qualifying diameter for. And there's our product. Again, real simple and quick. We take a look at that. It's going to look the exact same as our model. It's just now this is a Microvellum product that we can manufacture. All right, pardon me. I'm sure there are some questions that have come through, Clay. I'm sure I probably went through kind of quick. I did want to just kind of brush up on this. You had mentioned before that these sessions are recorded. So, any of the users that would like to go back through the previous days, I'm sure Clay can make that available to you. So you can kind of get caught up to speed and pick up some of the other things that we talked about over the last couple of days. I do want to get into the the custom product builders. Show you kind of how you can make custom cabinets. I've even had to use it for an occasional die wall or two. If I've got a die wall that is tapered from one end to the other in height, you can use these the custom product builders for those. It's pretty cool. Let me open up the chat, see if we have any questions. All right, I'm not really.
I think we got most of the questions answered and a lot of sharing of files and sample work. So it's great to see how others are applying these tools.
All right, awesome. Yeah, so sorry, if we didn't get to any of the questions, or if we kind of skipped through this kind of fast. Like I said, the other sessions, if you want to go back and watch those, they'll go a little more in depth, especially day one. Day one went more in depth on smart layers and things like that. So go back and review those if you need to. I do have another instance of Toolbox open up. All right, so this is just a blank drawing. I have nothing in here. This is where I wanted to kind of showcase the custom product builder. So those are the two different options with these solid modeling tools, right? We can build a product extruded along a construction path, or we can build a custom product based off of different profiles, different properties, even existing solids. So I do want to jump into that. So prior to this, what we're going to create is a custom box, kind of more of a credenza type thing, maybe more of a piece of furniture that will have drawer boxes in it. Eventually, we're not going to, I'll show you how you can do that through the product prompts once we get this product started. So what's really neat about this is, it's simple geometry is what you're working with to make these products. So I'm just going to start with a rectangle. I'm going to use the dimension input, make this 72 inches, and I'm going to go 30.5. Yeah, you can see I was way zoomed out there. So this is just the overall size of our carcass, right? I'm just going to use lines now to start making this product. I'm just going 18 inches from center both directions. That'll give me 2 divisions here. I'm going to add some parts going diagonally here. Now, you'll find as you go through the software that anytime you're using like a diagonal part, it's usually good to come off from the corner a distance. Sometimes you might need to play with where those are, just so you don't end up kind of getting some either weird mitered parts or anything like that. So I'm just going to add my diagonal lines in here. They're going to represent some slanted shelving. I'm going to do the same thing on the other side. So I'm just going to mirror these. All right. So that's the overall shape that I want to create. And that's all I need to draw. From there, we can go right click to add a product. So my different options for creating these custom products, right? Custom product starter, top view, side profile, front profile, or from existing solids. We're going to use the front profile in this example. You can specify what material you want your carcass parts to be made out of. I'm just going to use the plywood. It's just a quick, simple one to use as an example. Product smart boundary. What this means is it's going to look at the boundary that we drew, that first rectangle that we drew, and with that turned on, that means our product will be constrained to actually be 72 inches by 30.5 inches. With that changed to false, it's going to line our parts up center of our material thickness to that line. So we'd end up being, 72 3/4 by 31 1/4, right? We'd grow our box depending on our option here. So I'm going to leave that for true. Product boundary joint type. How do we want to handle these joints? Are we going to miter the joints? Are we going to dado, dowel, just do a butt joint, or we can do a dado dowel? Let's have some fun. Let's do a dado dowel here. Internal joint type. So this is going to be our divisions and these slanted shelves. because I have the slanted shelves, I'm going to leave that at a but. Create back. Do we want the program to create a back for us? True or false, off, on. I left it true, so it's going to add a 3/4 inch back in here. Joint type for back, I'm going to leave this at none because I want to show how we can add different kind of joints into our product at a later step. So I'm going to leave that set to none. Going through, these are the different parameters for the different kind of machining options we have, right? So we selected Dado dowel. So we have Dado options here. We also have dowel parameters here. So, depending on your machining, your machine file, the drills you have accessible, you can, swap between those. All right, let's call this just a credenza. All right, so once I have that set up, now it's asking me to select my objects. I'm just going to window the whole thing here. It's now asking me a point to place the carcass. So I'm, click a point out in space, throw this into a southwest. So we've got the start of our product here. Notice, we don't have the machining in our divisions. We don't have any machining on our back. So let's go ahead and we're going to add our machine. We do see that we have our Dado dowel set up here. So to add joints to our product, we're going to come over to the custom tools, and we're going to be working with the joint tools here. So we can get into the properties of a selected joint. We can remove joints and the different types, right? We have butt, we have dado, miter, half lap, and then also dowel and dado dowel. So I'm going to use the dowel, right? We have parameters again that we can set up for that. I'm not going to make any adjustments to that. And what it's asking for is a 2-part selection, right? It's asking for us to select the male part, which would be our division, and then our female part. It's going to add the dowel machining in there for us. It's going to keep that command open so I can just work through this product. Oop, I selected it twice. Okay. So we've added the machining to our divisions. Now let's add some dados to our back. We're going to dado this into our sides, top and bottom. So I'm going to go to our dado joint. Again, we can set up those parameters. And I need to select my back first and then my side. It's added that dado in. I'm going to select my back first and then my bottom. Select the back first and then my top. Sometimes, working in a wireframe can be a little daunting at times. There's just a lot going on that you can see. But when you're trying to work with, parts that are in the background and you're trying to select edges, it's just going to take some getting used to be able to work through those. Again, select my back, select my side. So now we've added our dado machining for our back. All right, now at this particular point in time, I'm going to say this product is complete. So we can save this now as a Microvellum product. So I'm going to select our product here, right click, save. Yes, I want to save the drawing. I'm going to save to our current project and draw, pick a point. So here we've got our product, right? Throw this into a different view. Okay, now I had mentioned earlier, that we can add, some sub-assemblies to this through the sub-assembly prompts. So I'm going to select on my product prompt icon, select my product. Here we have our prompt interface. Now this was created using the custom product tools, so it's stripped down. All we have width, height, and depth, right? Nothing else built into this. You could spend some time adding some spreadsheet love to this to make this a parametric product if you wanted. It's definitely another session, if you will, maybe even just some remote training to go into everything you can do with the spreadsheets. I'm a nerd. I love working in the spreadsheets. That's, in my opinion, this is just my opinion, that's where the power of the software resides. I know some people are scared of spreadsheets. Tell you what, I didn't know what a formula was coming into it, and I've been able to create some pretty crazy cool custom products, fully parametric. It's not as daunting as it may seem, and once you realize what you can do in the spreadsheet, man, there's no limit. I'm going to right click here, go into our sub assemblies, and over on the left side. Now this question actually came up in the session before. Somebody had asked, how can you add a sub-assembly that doesn't exist in the product? Well, this is exactly how you're going to do it. So over here on the left side, we have a list of all the sub-assemblies we have in the library. I'm looking in particular to the sub-assembly inserts, and then into the doors and drawers. I'm going to use this 3-drawer sub-assembly insert. So what's nice about the sub-assembly inserts, it's going to include everything that we see in that picture there, right? It's going to have our drawer fronts, it's going to have our drawer boxes, and all the hardware that goes with it. So to add that, it's just a simple double click, and you can see here it's asking us to pick corners on where we want to place this. So by selecting that, right clicking, using pick corners, I can come in here, select the bottom left of the front of my product, and then the top right of the front. So that's going to give me my width. It's going to give me my height. Now for the depth, it's looking for defined names that don't exist here. I do know that, it's just going to be depth. And I do know our back thickness is 0.75, right? It wants me to give my opening depth here. So I'm just going to type in a simple formula there. Click OK. Let's watch this thing draw out. All right, so now we've created this custom product. That in other cases that might not be the simplest thing. I know in the session before, Roman went through creating custom products using product starters. Or modifying an additional or modifying a cabinet to have additional sub-assemblies. I will tell you this sub-assembly, right? These two little angled shelves, that doesn't exist in our sub-assembly inserts. That's something you'd have to create like we did here. So part of this could be done as a product starter, but I wanted to show you just what you can do with these tools. This is a simple product, I understand, but again, this is a product that can now go to the shop. If I turn this into a wireframe, we'll be able to see the drawers in there and the hardware associated with that. So really neat tool to be able to use. Actually, I'll just keep it in a wireframe. So I had mentioned earlier that I've had to use this from time to time for, a die wall that tapers from one end to another. So I just want to go through kind of what that might look like if you run into a situation like that and need to have a wall that's going to get higher from one end to the other. So I'm using a polyline. Anytime you're working with a smart boundary, you do need to work with a closed polyline. So let's just kind of make it a little simple here. I want to go back 0.72, 72. Oh, wait, I went 84. And then we're also going to drop it down, 12 inches. And then I'm just going to close that out by typing C, enter. So if I have a die wall, right, that I have to build, or maybe even a section between two die walls, it's going to be a transition piece. I'm going to come in here, I'm going to add some studs. I'm going to extend those up to the top. All right, so that would be a pretty basic front profile using the same steps here. Add, still going to keep that custom product from front profile. Let's call this tapered wall. Now the boundary joint types, I'm going to actually set this to butt for now so that we can add our own joint machining in here. All right, window the whole thing. It's going to ask us to place this product. I didn't change the depth here, so this is a really deep die wall. Oops, I actually did a back in there too. So if I needed to remove that back, I can come into my parts, right click, and remove. Right, so I've taken that out. Let me take a look at this in a conceptual drawing. We can see we have our studs in here. If we wanted to take that a step further, and let's add some joints in here. I'm going to do a dado joint at the bottom of all my studs. Now, I could do it on the top, but that would probably be hard to machine, unless you've got a 5-axis CNC machine that can dado those on an angle. So we're just going to do it on the bottoms here. Let's see, this might work. I haven't tried this. It did work. All right, so I'm dadoing my ends into the bottom plate as well. Okay. Let's do a butt joint the other way. So select part to trim first. So be that part and that. So now my plate runs across the top, across the bottom with everything dadoed in. So, again, these tools are, if you have them, don't try and limit yourself. Like I have said in yesterday, don't try and limit yourself to only using one part of the tool, right? Don't try and get yourself stuck using the extruded product builder if you need to build a tapered wall. You're going to spend a lot more time using things like press, pull, or subtract to get this product to taper from one end to another. Take advantage of the whole spectrum of the tools that are available to you. This got us most of the way there, right? And also, don't get stuck thinking that you have to use the tools to complete this product, right? If there's maybe machining I need to add, it might be easier to maybe make some wire chases by subtracting a shape through all of these, or it might be quicker to add that into the part using the draw part in 2D. There are 1,000 ways to get to the same end result. So don't limit yourself. Don't get stuck thinking that, oh man, I can only use these tools. No, take advantage of what in just 3D AutoCAD modeling, or as Clay had mentioned, in previous days, you can import from Inventor, you can import from SolidWorks. So if there's something else that might need to be dropped in to this product that was easier to create using one of those others, maybe just due to AutoCAD's limitations as far as the 3D portion goes, import that into your drawing, add some smart layers to it, and move on. You don't basically what I'm getting down to. Don't limit yourself. Think outside the box all the time. You've got a job to accomplish. Don't get hung up on thinking, well, the extruded tools can't make a tapered wall. No, but the custom product builder can. Use a combination of everything to accomplish the end result, right? Which is to get something out to the shop floor that your guys can assemble. Clay, we've got about 10 minutes here. I'm just going to quickly look through the chat, see if we have any other questions. Looking through to maybe you had time to read through them all.
Yeah.
I haven't.
Yeah, there's quite a lot of chatter going on here today in this topic. So there's some questions about the 50.7 product library. I had made a comment about that feature that you showed off that allowed you to bring that subassembly from the product library into that custom tool. That's available in the latest library. So you can learn more about that library. Coming up later today, 1 p.m. Pacific time, we'll have Lenny Sienna, who has been in charge of that development of that library. And he's going to be reviewing some of the items that are included in the release notes, the things that we've been changing, things that we've been adding, fixing in that library. And so you're going to get a sneak peek at what to expect with that. And as far as the download, it will be available on our community site a little later, hopefully before he gets started with that session at 1. So that's where we're at with that. There was another comment that came in from, I think that Amy answered. There was a question about how what you're showing might apply to other processes. For example, maybe you can comment about this, James, maybe in your previous work, working as a customer, but for stone, for glass, for metal, other ways that you can use this, what you've shown here, to create parts that might not be wood products or wood parts.
Absolutely. First off, the most important thing that you would need prior to that is a tool file configuration created for you to work with whatever machines you may be using to manufacture your stone and metal, right? Making sure that those tool files have been set up for you so that you can use those is going to be your first step. But in reality, I'm just going to come in here to our project spec groups. Let me drag this over. Right, let's open up our material file here. So anything in here that you see is not the only thing that you have to work with. You can add materials in. So going back to the question of solid surface, right? If you're manufacturing solid surface, you can add that in here. There are some examples already built in, but whatever else you need to add into that, add those materials. If you're working with a metal, add that metal in here. Again, making sure that you have a tool file created and that connectivity to create the G code. That's probably the first limitation, if there's any. As far as I know, I haven't seen a machine that we can't connect to. maybe Clay has some more insight on that, but so far I haven't run into any cases where we haven't been able to create code for, a different machine. But, anytime you're trying to nest a material, I will say this, it has to exist in your sheet stock library. These other categories here will not manufacture or nest on a sheet. So if you're trying to nest metals, you're trying to nest solid surface, it does have to exist in the sheet stock library. And then as far as being able to use that inside of the product, you're just going to assign that material to that part.
So what if you're not trying to nest it? What if there was an example of a bar that was submitted earlier, had some metal pieces on it? What if you wanted to account for that? How would you handle that?
And you just wanted to create a cut list for it?
Cut list, order information, linear links?
Yeah, same thing. First, start off in your material file by adding that material into whatever category it's going to fall into. If it's something that you're just trying to account for, maybe it's a bar rail foot, right? Mm-hmm. You're going to add that into your hardware. If it's a buyout item, maybe it's a metal strip, right? It's a flat bar, it's an angled, it's angle iron, whatever it is, you can add that into your buyout library. And then depending on how you have your properties set up, whether that's going to be a per each kind of item or a linear foot kind of item, you can set that up. And again, it's just a matter of adding that part into your product, whether you are drawing it out using the solid model tools, or you're just going to get, down and dirty and jump into the spreadsheet and just start cut listing all those parts. Mm-hmm. There's, like I said, there's a multitude of ways to accomplish that. For example, I've used this software just for some of my own personal things, which I've included things like metal legs, metal table legs, or I designed a garden shed, so I added the hinges and the latch into my hardware, so that when I processed it, I had everything that I needed. I went to Home Depot, I bought all the materials, I knew exactly what I was going to need. I had my cut list of how I needed to cut my studs, and turned a project that probably would have taken me some time to figure out, just going out in the backyard and starting to cut stuff, took the time down significantly. I knew where and how I had to cut my studs, where to place them, and don't limit yourself to just cabinets. You could use it to design a house if you really wanted to, take the time to learn how to do that. It might take some time on the processing end of things, but there's really no limit to what you can do with it.
Yeah, that's a good point. And one of the benefits too, as we've highlighted, I think a few times, and if you did not watch our session yesterday, we had a little bit of a show and tell later in the afternoon yesterday, where Matt Davies, one of our reps from Australia, showed off a project that he was working on for a customer, and they build travel trailers. So the entire travel trailer, down from the metal pieces on the chassis to the tires and wheels to the air conditioner package, all of those things were accounted for. And so as we highlight here, simple metal extrusions, whether it's a bar foot or a bar rail or whatever it is, as long as it's set up properly and as long as we have the pricing data in there, you can get those accurate project costing data from that.
Yep. I did see a question here from Rod on what challenges are faced to get sub-assembly, inserts from older libraries to be able to be dropped in. Most honest answer is going to be some spreadsheet love, and it's going to make sure that any of the variables that are missing from the local product would have a global reference. If you can fix those, there really is no reason why any subassembly couldn't be dropped into any product using pick corners. The limitations are the local prompts, that are feeding down into the formulas of the subassembly that don't exist. Another thing I've done is I've gone into a product starter and just copied all the prompts from that and dumped it in so that they exist, define my names, and then you won't run into as many limitations when inserting those sub-assemblies. So that, a couple ways you can get to that, Rod.
Yeah, definitely a valid point there. We are not forcing you to work with that. That was just a feature that we wanted to have included with these custom tools for a while. And so as we were producing this next update, or the latest release here for the 50.7, that was one thing that was added. And you're right, you explained it exactly right there, James. So you can, as we referenced earlier in other sessions today about cherry picking, I think Roman highlighted that, and others, about cherry picking data and learning from the way that we've changed and improved the latest libraries. This can help you apply those same changes to your own library. And in this case, being able to utilize the subassembly inserts.
Right. So, just to showcase something unique here, this is a submarine playscape that, a customer was requesting a demo for. So this was all done using these solid model tools. This was the analyzed product. You can see there's two products that got a little glitchy, or two parts that got a little glitchy on the analyzation. In that whole product there, if I've got two parts that I need to modify some machining for, I'm miles ahead than trying to draw each of those parts out individually to get that. And what was cool is when I nested it, it actually created those cutouts, those elliptical cutouts. I mean, it was pretty impressive to see what it did there. So, it's just a matter of getting in and playing with it and seeing what you can come up with.
All right, let's take a look at the chat. I think we've got most of them answered. No, there's one last one. We have about 1 minute left. I don't know if you can answer this in 1 minute, but it's from Frank. He says, can you change the depth of that angled die wall now that you realize it's too deep, or would you have to restart?
I should be able to do that by using the properties, right? Edit product here. I'll tell you what, it's easier just to come in here. I'm going to remove that.
I'm not sure if he was talking about this product that you're working on here, or if it was the previous wall unit that you were working on.
So, let's go something more realistic for a die wall. All right, so there we go. Like I said, sometimes it's easier just to start over. It took us no time to do that, rather than, trying to find the time, how we could modify that, or using press pull to shrink it, whatever need be. Now with a product like this, you could add some parametrics into the spreadsheet to where you could control the depth of it if need be. But for these custom products here, it's just a matter of changing that field and getting back to it. So anyway, I'm starting to get into Ed's time. I don't want to take away from what he has to talk about. So thanks again, guys and gals. I appreciate the time and look forward to tomorrow.